Okay, so we're gonna do 3.2, right? So 3.2, let me write down. The derivative is a function. So derivative of a function at a given point gives us rate of change or slope of a tangent line to the function at the point, right? So we did that last time. Let me write down definition, derivative function. So let f be a function. The derivative function denote by f prime. We read f prime, right? Is the function whose domain consists of those values of x such that the following limit exists. So we are using the notation f prime of x. Read f prime of x. Okay, then we have h approach to 0, limit of f of x plus h minus f of x over h. Okay, so here, this one, derivative of function. So we did that last time. We have a derivative function at one point, right? At a, right? Then we have f prime of a last time, the limit x approach to a, we have this formula. So chapter section 3.2, we are using this one, f prime of a. Okay, so we do that. Oops, h. Limit h approach to 0. A plus h minus f of a over h, right? So we did a 2 formula. So alternative, the formula, right? We are using that, but this time it's a derivative of function. That's why we are using x instead of one particular point at a, right? Can you see the difference? All right. Now, we called differentiable function. Differentiable function is the one in which, let me just write. Differentiable function f prime of x exists on its domain. All right, so let us do example. So find the derivative of f of x equal to square root of x. Okay, so we're gonna use the formula above there. So limit, let me denote f prime of x. So limit h approach to 0. So x plus h, right? So we had experience, maybe several experience, right? Or less, a little bit. So we're gonna plug in x plus h into x, where is the function? Into there, okay? Okay, so then that is x plus h in the radical square root. And f of x, we just keep that square root of x over h, all right? Now, do you know what technique, what kind of algebra technique, algebraic technique we are using it?
I think it might be called the reciprocal. I forget what it's called, but I think you can put a plus where the negative sign is and multiply.
Oh, conjugate. Conjugate method. Multiply by conjugate. Excellent.
Conjugate. Thank you.
We're gonna multiply by conjugate. So that is the same format, just using plus in the middle. Okay. So does here, because we multiply by 1, right? So technically we multiply something, but literally we did not do anything because multiply by 1. Right? Now, okay, so we have a minus b times a plus b, which is a squared minus b squared, right? So that is x plus h, because we square them, we get the x plus h. Then we do square root of x squared, which is negative x, right? Then let us keep the denominator. So we did that last time, right? Keep the denominator. Cannot see well because name tag there. Following my name. All right, then x minus x, which is 0. Okay, since we have experience, let us do this way, okay? So x minus x is 0, and then we can simplify h over h, okay? Since we're not taking algebra, we can do that, right? So we have the algebraic experience. So makes sense, okay? So x minus x equal to 0, then we have h over h left, so simplify as 1. So I don't teach it this way in algebra, of course. So then we have h approach to 0, we have 1 over x plus h plus square root x, right? Now, we can plug in when h approaches to 0 because we are safe, not undefined, okay? So this will be 1 over x plus 0 plus square root of x. So what do you get this one?
1 over square root of x squared.
So it's 1 plus 1.
Or, yeah.
1 plus 1 is 2, right? So 2, yeah. It's yeah. 1 over 2, yeah. Okay? So we got that. So 1 over 2 square root of x. This is the answer, right? And if they want to know, about the specific, the point for the x value, then let's say that, we want to about the derivative when x equal to 2, then we can plug in x equal to 2. Then we get 1/4 in this case. All right? Okay, let us move on. Let me erase. So let's see. Find the derivatives of the function f of x equal to x squared minus 2x. Okay, so let me write down formula for you. So we have f prime of x equal to limit h approach to 0, f of x plus h minus f of x over h. Okay, now x plus h, we're gonna plug in into the function. More specific, we're gonna looking at into the substitute 2 into variable x. All right. Okay, so let us do this one. Limit h approach to 0. Now x plus h squared minus 2 of x plus h minus f of x, we just copy down x squared minus 2x. Okay, over h. Let us do this one. X squared plus 2xh plus h squared minus distribute 2x minus 2h minus x squared plus 2x, right? Over h. Now let us simplify. Who has good eyes? That's it, right? Can you double check? All right, then we get this. Since we had the experience, let me put this one like a factoring out so that we can save the time. We have a 2h there, huh? Minus 2. Okay. All right, then let's see. H over h is the one. H approach to 0. Now, we can substitute when h approach to 0. So 2x plus 0 minus 2. Since we substitute, I don't want to write down this one here. So we get 2x minus 2. So this is the derivative of the function, which is x squared minus 2x. Okay, and if you want to specific point, we want the derivative of a function at x equal to 3. Then we substitute 3. Then 6 minus 2, which is 3. 6 minus 2 is 3, 4. It's the derivative of the function at the point when x equal to 3. Okay? All right, let me talk about this one. So we had the function notation. We just did. Then we conclude f prime of x equal to 2x minus 2. What if we change that, the equation notation, which is y, right? Then we can express this one y prime, just y prime, not the x. Y prime of x equal to 2x minus 2, or we can express like a dy over dx equal to 2x minus 2, because we said that d over dx, y is in the y in this case y in this case is x squared minus 2x. Okay. So we can express this as x minus 2. All right, so let me talk. So we took dy over dx. This is Leibniz notation. Let me spell Leibniz notation. Okay, so how did we find derivative? So slope of secant line is the same as, say one more time, derivative of a function, a point. Let me see, derivative of a function. Now at a point, it's the same as limit of the slope of secant line, right? Which is tangent line, right? Slope of a tangent line. Limit of the slope of secant line, which is same as the slope of tangent line. So we have like this, the previous section, we have f prime of a equal to f of a over x minus a. This is the slope of secant line, which gives us the limit, right? Then this is the limit of secant line, which is the slope of a tangent line, right? Then can you, do you agree with this one? dy over dx. I'm gonna write down limit of, okay, limit of the slope of the secant line, okay? How about secant line first, slope of the secant line, which is change in y from the algebra, right? Change in x, right? Then we take the limit when the denominator approach to 0. So h approach to 0, same, right? We did the last time, okay? So delta x approach to 0, okay? So I'm just telling you about the notation, dy over dx, okay? All right, graph derivative. Let's see. Let me erase. All right. we have, let's see. Okay, so let me draw. Little bit ugly. It's better. Okay, this is 7. This is -2. Then let us write like that. Okay. Okay, let us analyzing the graph. Look from here to here, the graph decreasing, right? Oops. Until here. Can you see that? This is the flat. So decreasing. Okay, and then this is the flat means zero slope. Okay, so let me write down f is decreasing. Tip. So what's the slope? It's also negative slope. Can you see that? Can you see? So negative slope means below the x-axis. Okay, so let me draw below. So until -2, right? So below. Okay, a little bit straight line. I want to make a little bit smoother. I'm not good in that. How about like this? Okay. Now, after when x equal to -2, it's increasing, right? Increasing until here, right? Flat. So let's see. This is at 3. So zero slope. Okay. So f is increasing. F is increasing. Can you see the slope? It's also positive slope, right? So positive slope means above x-axis. Okay, so the graph will be above x-axis. Until flat. Flat is 3. So zero slope corresponding 0 here. Okay, zero slope corresponding 0 here. Can you see that? Okay, now after 3, decreasing again, right? So decreasing, decreasing, decreasing. So decreasing. So decreasing means the negative slope, right? Then below x-axis. So we're gonna just draw like that. That's how we graph the derivative of the function. So let us label. This is the f of x function. Oops. And this is f prime of x. All right. Okay. Let us talk about derivative and continuity. I'm going to erase this one. Theorem. (3.1) differentiability. I read the differentiability, right? Ability implies continuity. So let f of x be a function and a be in its domain. If f of x is differentiable at a, then f is, so I'm denoting the continuous like a CTS, right? We know that at a, okay? So CTS means continuous, right? Okay, so every time the function is there with the domain, then we say that the function is differentiable at the specific point at a, then f is continuous that point a, right? But then the reverse. So we do this way is true, or reverse is not true. This is why we don't use if only if, which is IFF, right? Remember we mentioned about the notation, right? Means that f is continuous at a, then if f is differentiable at a. Okay, look, they give us the example. You guys see here? Why so quiet? Absolute value of x, we know this function looks like that, right? Oops. Oops. Really? Oh, sorry. If you want to talk, please unmute for yourself. because I was trained the person, right, earlier, how to make a mute. So now mute for everyone. I see. That's why it's so quiet. Why I cannot make this? Oh, maybe I do it then. So if you want to talk, please unmute for yourself. If you don't mind, your voice is in the YouTube video, right? So like that, okay? But then look, how do we show differentiable at A, right? So let's talk about when x equal to 0. We take the limit, x approach to 0, okay? So I was talking with a student during office hour. H1 is more algebra work, so we are using x. Okay, over x minus 0. Then, it's not so good. So we do absolute value of x minus absolute value of 0, x minus 0, right? Then absolute value of x, absolute value of 0 is 0. It's that, right? But then note, by definition of absolute value of x, we have definition. X, when x is greater or equal to 0, right? Negative part, when x is less than 0. This is the definition of absolute value. Then there's two conditions. We do separately from the left, from the right, from left. So from left, we're gonna use this one, okay? So that this is x over x with a negative, right? Then we simplify. Then we get x approach to 0 from the left is -1, which is -1 because constant is constant, right? Let us find when x approach to 0 from the right. Then we are using this one, okay? So we get positive x over x, which is, we simplify, then we get from the right, sorry, then we have a positive 1, which is 1, right? So the limit must be agreed, right? -1, then we can say, oh, limit exists when x approach to 0, absolute value of x over x equal to 1 or -1, right? But then the number is not matched. Number is not agreed from left to from right, right? So does not exist. Okay. It's a continuous, right? Continuous everywhere. Absolute value of x, but not differentiable at x equal to 0. Because we just showed that, all right? By just looking the graph, looking at this graph here, what's the slope of this one? It's -1, thank you, right? What's the slope of that side?
One.
Thank you. Okay, so if we draw this one, f prime of x, that is left side is -1, and then open at 0 when x equal to 0, and then right side 1, like that, okay? For your reference. So we say that this is a corner, not differentiable. The corner like that or like that, okay? It's not differentiable. Okay, let me erase. So please write down there. I did not write down, I just say that. So please include the earlier lecture. The function f of x equal to absolute value is continuous at x equal to 0, but it's not differentiable at x equal to 0, right? I just said that. I didn't write down. Okay, how about this one? We have f of x. How about g of x? Because we've been using f of x. G of x. Let me see. Equal to square root of cube root of x. Okay. Okay. Let's make that limit g prime of when x equal to 0 equal to x approach to 0, same, x approach to 0, then cube root x minus 0 over x minus 0, right? Okay, this will be cube root of x over x, okay? So cube root of x means x to 1/3, right? We have a denominator 1, which is 3 over 3, right? And that is x to the negative 2/3. That is same as 1 over. We can write down 2/3, or you can just say this like cube root. It doesn't matter. I don't care. So cube root and x squared, right? Okay. Now, if we draw this one, decimals. Okay. So this one will be like that. Then when x approaches to 0, what is 1 over cube root of x squared? What is this? So from left to from right is the same thing, right? So what do you get? Unmute for yourself, please, and talk if you don't mind.
Is it x equals 0? That's what it looks like.
So I'm talking about the limit. What's the limit? When x approaches to 0, what's the limit of 1 over x to the 2/3?
Is it infinity?
Infinity, yes. Positive infinity, right? The graph goes to positive infinity here, right? Both of them. So we can conclude the positive infinity, right? So the limit does not exist, okay? So limit exists, then should be number, okay? So then how do we say this one? So this graph is cube root x. This one looks like that. I want to make it more steep. All right. This graph is like this. Okay, let us talk about that. So it's a little bit flat slope, right? And then looking at this one, it's almost the vertical, right? And then the positive slope. Can you see that? So we called this one is the vertical tangent line. At x equal to 0, okay? So here, so vertical tangent line. How about that, okay? So if vertical tangent line, then there is no derivative, okay? Not differentiable at the point. So at corner, vertical tangent line, okay? And there's another one which is not continuous, right? Let me erase. So we did this one before. When you talk about the discontinuity, h over x. Yeah, please include earlier one. I didn't. Conclusion. G of x equal to cube root of x has vertical tangent line at x equal to 0. So it's a continuous at x equal to 0, but it's not differentiable at x equal to 0. Okay, so conclusion. Okay, let us do this one. H over x. We have negative x squared plus 4 if x is less than or equal to 3. For x minus 8 if x greater, oops. Than 3. So previously we did this one. So I don't want to do again. This one is jump. We had this one like a 3 and then like that. Okay, so this is not continuous at 3. Okay, so not differentiable. So basically, couple problems from the previous one is continuous but still not differentiable, right? But this is not continuous and not differentiable. Okay. All right. So higher order. Thank you. at. Higher order derivative. So we derivative of the function. On top of that, we can derivative again. On top of that, we can derivative again. Again. So we have a higher order derivatives. Okay. So how do we denote? Like we have a position function. Okay. Then we derivative. Then there is the velocity. Then we derivative velocity. Then we get acceleration. Okay. Now, how do we indicate symbol of higher order derivative? Okay, so we're using f prime of x with double prime. We said that we do 3 derivative. Then we're using actually 3. Then 3 prime. Okay, then after 3 is too much, right? Then people cannot follow. Oh, they have to count. Oh, how many there, right? Then they're using 4. Okay. Until so many. Then if they're using y prime, y second prime, third, then after third, they don't use that. Okay. And how about we talk about the dy over dx, right? Then second, third, and fourth. They're using number, right? From first, second, third. Oops.
The bottom part is kind of cut off.
I know.
Let's say d to the second prime y above d to the second prime x. Is that what it says underneath?
Yeah, x, not the y. Okay.
Okay.
So if you have a hard copy of a book, they made a mistake here. That's why I'm following that. So it should be x, right? Let me write down. I'm writing. Please wait. Right? Okay? X, right? And x to the n power. Is okay? Okay. Let us do one problem that I wanted to do acceleration, but no time. Just same concept. So let us do just this one. Okay. We have f of x equal to 2x squared minus 3x plus 1. Find f prime of x. Okay. Then we're gonna use the limit h approach to 0. Okay, so that is, we substitute x plus h into the function, right? So that is, then f of x, we just copy down. Let us do algebraic or h. So x squared plus 2xh plus h squared, the first term. And then we do times 2. So 2x squared plus 2xh, which is 4xh plus h squared, which is 2h squared. Please correct me if I make a mistake, okay? Negative 3x minus 3h plus 1 minus 2x squared plus 3x minus 1 over h approach to 0. Okay, who has good eyes? Simplify. Me first. I won. I'm winning. Okay. I won. All right, then h has the common, so we do factoring out h. So 4x plus 2h minus 3 over h, and then we simplify. Can you see that? Every time it says very similar work, right? Processing. Oh, I don't get it. Sorry. Later. I'm busy. I want to finish this and then the second derivative. Okay. So we have, let us save the step. We have 4x plus 2h minus 3. So let us substitute h approach to 0, right? So we have 4x plus 2, 0 minus 3. Then we get 4x minus 3, okay? Good. Now, we want to find second derivative of this one, okay? Now, this is f prime of x, right? We do again. Then that is x plus h, we substitute into the f prime of x function, right? So which is the 4x plus h minus 3, right? And minus, in this case, f prime of x, right? So that's here, okay? Because we substitute into f prime of x. Now, for x plus minus 3 over h, and then I forgot the limit. This is happened all the time in your paper. H approach to 0 for x plus 4h minus 3 minus 4x plus 3 over h, right? Now, who has good eyes? Okay, then we get simplify. It's a constant, which is 4, right? Okay, right on time. So let me save.